In the last couple lectures, I've mentioned that there's a distinction between two different types of argument. Some people will argue there's more, that this distinction doesn't capture everything, but I really don't know about that. I'm not sure which way I come down, but I do think this distinction is very useful, and it probably captures most of what's going on in most types of argument. So I've talked about deductive arguments and inductive arguments. In this lecture, I want to talk about the difference between the two of them and, hopefully put you guys in a position to distinguish between the types of arguments. In this class, we're actually going to focus a lot more on deductive arguments. Even in these argument lectures, we will be focused on deductive arguments a lot more than inductive. And when I make an argument in this class, unless I say otherwise, I'll be presenting it as a deductive argument. And I'll say a little bit more about why that is toward the end of this lecture. But I do think you should be able to distinguish between deductive and inductive arguments. And I think this is really helpful when you're trying to figure out what kind of argument someone is making and whether it's a good argument. I think that a lot of times people have this tendency to treat an inductive argument like a deductive argument. And when they do, they hold it to an unfair standard and they end up making some pretty stupid mistakes themselves. I think this is pretty common. So I do think even though we're going to spend a lot more time on deductive arguments, I do think that's useful to keep in mind and useful to be able to spot when people are making this particular mistake. So the real difference between deductive arguments and inductive arguments are the ways that the premises support the conclusion. In a deductive argument, if the premises are true and the form of the argument is good, then the conclusion must be true, right? So a lot of times I'll talk about the premises of the argument, whether they're true, and also the form of the argument, right? And I think this is a distinction I'm going to keep harping on. Often when you look at an argument, it's useful to think of it kind of like a building, right? If you want a building to stand up and not fall down and not leak and not crack apart, and if you want a good building, a good house or whatever, you need two things, right? You need a good plan, how you're going to fit the pieces together. You can have the best material in the world, and if you put it together the wrong way, strong wind comes, it's going to fall down, right? I don't know if you've ever seen, there's a Simpsons where Homer Simpson is trying to build this outdoor barbecue pit. He buys the top of the line expensive model. It being Homer Simpson, he doesn't read the directions and just throws it together, and it's a disaster, right? So, good materials, bad plan, not going to work. Best plan in the world, though, you can have the best plan in the world for a house, and if you try to build it out of cardboard, it's probably not going to be super durable, right? So a good argument, you need a good form, and you also need good premises. So, deductive argument, back to what I was saying, if the premises are true and the form of the argument is good, then the conclusion must be true as well. And if you guys are perceptive, you're probably thinking, well, he's saying the form is good. That is super duper vague. What does he mean by that? Yes, it is, and I will talk more about what it is for the form of a deductive argument to be good in upcoming lectures. An inductive argument, if the premises are true and the form is good, the conclusion is likely to be true. No matter how good your premises are, no matter how well you fit them together, in an inductive argument, all you can say is that the conclusion is likely to be true. And now look, I think a lot of people will act like inductive arguments are inferior sorts of arguments. They're not, right? They're often pretty useful in their places. And when we say likely, sometimes likely can be very, very, very likely indeed, right? 99.9%. Or add some more nines at the end there, right? But always there's some chance with an inductive argument, no matter how good the argument is, there's a chance the conclusion's false. I'll give you guys some more examples. I think this will be clear to y'all. One way to think about this is deductive arguments. If you think back to high school geometry, or if you're taking math classes with proofs now or whatever, deductive arguments are the kind of arguments you see there, right? Inductive arguments are the kinds of arguments you see in a lot of the other sciences, right? Particularly, like a lot of times we'll see this in medicine and biology, right? If you think about arguments for the effectiveness of COVID vaccines or COVID treatments, we give it to 100 people, or more like 100,000 usually. Almost none of them get sick. Probably it's a good treatment. That's inductive, right? Anyway, let me give you guys some more examples just to hopefully make this clear. So this is an incredibly simple deductive argument. Again, start simple, even though it's kind of silly, just to make this clear, right? Mr. Whiskers is a cat. Mr. Whiskers is orange. So some cats are orange, right? If Mr. Whiskers is a cat and he's orange, we know that at least one cat, so some cats, are orange. A more complicated deductive argument, right? This is, I don't think they ever went over anything this simple when I did geometry, but again, these are the kinds of arguments you'll see in geometry and math. Those turn a lot of times on deductive arguments, right? The three angles of an equilateral triangle, one where the sides and the angles are all equal in measure. The angles of a triangle always add up to 180 degrees. 180 divided by 3 is 60. So each angle of an equilateral triangle is 60 degrees, right? If these premises are true, and they in fact are, you can't imagine the conclusion being false. Same with this one. If Mr. Whiskers is in fact a cat, and he's in fact orange, there's no way you can imagine that at least some cats aren't orange, right? Some in the sense of at least this guy, right? There is at least one orange cat. Another deductive argument: a war is only morally justifiable when it has a goal that can be achieved. The goal of the war on terror is to eliminate all terrorism, but it is impossible to eliminate all terrorism, so the goal of the war on terror cannot be achieved, therefore the war on terror is not morally justifiable. Now look, and we'll come back to this, you might not think this is a great argument. You might disagree with some of the premises. You might say, well, is that really the goal of the war on terror? Is it really impossible to eliminate all terrorism? You might disagree with the premises, but the thing is, if you accept the premises, the conclusion cannot be false. We'll talk about this in a minute. This will be really important when talking about deductive arguments. We might not agree with the premises. The key thing is, if we do accept the premises in a deductive argument, or at least a good deductive argument, conclusion can't be false. Final deductive argument. This is the one basically that Socrates offered in the Apology. Death is the end of all existence, or after death there is an afterlife where good people are rewarded. If death is the end of existence, then death is not a bad thing for a good person. Socrates would say if it's the end of existence, it's not a bad thing for anybody, right? If there is an afterlife where good people are rewarded, then death is not a bad thing for a good person. This means death cannot be a bad thing for a good person. Socrates' argument, he doesn't quite say it like quite this clearly, but I think he pretty clearly means this to be a deductive argument, right? Death's either this thing or that. Either way, it's not bad for a good person. Therefore, death is not bad for a good person, right? If it's the end, then it's not bad for anybody because nothing follows after. We'll talk a lot more about whether that reasoning is really true in the coming weeks. But anyway, let's accept it. On the other hand, if it isn't the end, then Socrates thinks that good people at least will be rewarded in the afterlife. So either way, death can't be a bad thing for a good person. Accept it or not, we'll talk about whether we should, but this is a deductive argument. You know, as I said before, deductive arguments are kind of the bread and butter of mathematics. They also pop up a lot when we're talking about principles, moral principles, principles governing things like whether we know things. That'll be a reason we see them so much in philosophy, because a lot of times in philosophy we are talking about principles. Deductive arguments are good for talking about that kind of thing, in ways and for reasons that we will get more deeply into. All right, an inductive argument, on the other hand, like I said, if the premises are true and the form is good, the conclusion can still be false. A good inductive argument makes the conclusion more likely. The better the argument is, the more likely it makes it. But no matter how good the argument is, there's always some possibility the conclusion will be false, right? So, one that's probably on our minds a lot in Hampton Roads, especially if we ever go looking for a house, we buy a house, right? If you rent a house, you don't want it flooding, but, if you buy it, you especially don't want it flooding, right? So, is this land going to flood? You look, and if it's never flooded in the last 100 years, that's probably a good sign it's not going to flood next year, right? Not likely to flood if it's not flooded in the last 100 years. But here's the thing, right? Even if a piece of land hasn't flooded in the last 100 years, there's always the chance that next year is the year we get the rainstorm that's bigger than we've had in 100 years, right? Even if it hadn't flooded in 500 years, you can get the rainstorm or whatever that's bigger than you've had in 500 years. We don't have records going this far, but even if you could show that it hasn't flooded in 1,000 years, it's possible we'll get a bigger rain or whatever than there's been in 1,000 years, right? So this premise, very good reason to think this bit of land won't flood next year. We make the numbers bigger, 500, 1,000, it becomes even less likely, but there's always still some chance. Or another simple inductive argument. The Pfizer vaccine is 95% effective against COVID. Effective, I think, means that, 95% of people don't even develop symptoms when they get the Pfizer vaccine. So if you get the Pfizer vaccine, you likely won't get COVID, right? But again, notice even if you get this vaccine, it's very effective, but 1 in 20 people still get the disease when they have the vaccine, right? From what I can tell, they don't get it. Even the 5% who get it usually don't get very sick. The vaccine does some good even for people who get it. Pretty much nobody even in the group that gets sick gets really sick or dies. But nonetheless, even if you get the vaccine, there is a chance you'll get the disease, right? Contrast this, especially with my triangle argument, right? If these premises are true, angles always add up to 180, these three are equal. Divide 180 by 3, you get 60. There's no way you can even imagine that these premises are true and the angles don't come out to 60 degrees each, right? No chance whatsoever premises are true, conclusion is false. Even with good inductive arguments, there is always that chance that premise is true, conclusion false. One final example of an inductive argument. Studies have shown that most people cannot lose weight by exercise alone. Even many of those who lose weight through exercise alone later regain it, so you probably won't be able to lose weight and keep it off simply by exercising. Right? These premises give us reasons to think that the conclusion is probably true. Very sadly, probably true, right? I wish they weren't. Personally, I both really like to eat and I really like to run. And despite the really liking to run, it never takes a lot of weight off, right? It keeps it off. If you want to lose weight, you probably have to diet as well, unfortunately. Now look, one thing to notice here is that this allows for exceptions, right? If I give you this argument, you might say, well, no, the argument doesn't work. I can point you out this one person who lost a bunch of weight through exercise and they've kept it off for 20 years now, right? But that's perfectly compatible with everything this argument says. It just says most people won't be able to do this, right? That it's really unlikely. If one person does it, that's not incompatible with anything this argument says, right? And this is, I think, one of the ways that people are often stupid about inductive arguments. You see this with smoking a lot, right? You give a long argument to somebody. This is less common, but I remember when people started to first really, it got in the public eye that cigarettes were so terrible for you, right? There would always be somebody who would talk about some uncle or aunt of theirs who chain smoked their whole life and then died at 80 from something unrelated, right? But the arguments that cigarettes are bad for you, right? When people say cigarettes will kill you, it's an inductive argument, right? What they're saying is, well, you're more likely to get emphysema. You're more likely to get cancer. You're more likely to have a heart attack. Add all that stuff up, you're way more likely to die way sooner if you smoke. The fact that one person can smoke a lot and somehow escape the worst health, problems from it does nothing to show that in general smoking is bad for you, right? So, this objection people would always make, it's treating an inductive argument like a deductive one. Deductive ones don't allow exceptions. They don't allow a possibility that the conclusion isn't true. Inductive ones do. So always be clear on what kind of argument the other person is making. Don't treat inductive arguments like deductive ones. I've seen this a lot with the pandemic, especially people who should know better, right? I have a colleague and she was saying, well, at my age, from what they can tell, it's only got a 1 in 250 chance of killing me, and so if I get it, I'll be fine. And I think she's treating an inductive argument like a deductive one, right? Premises don't show that she'll definitely be fine. They show probably, right? And if there's a 1 in 250 chance you die, well, that's a situation where we should take the maybe pretty seriously, right? So always be clear what kind of argument you have. Do not treat inductive arguments like deductive ones. Sometimes if you do that, you'll just be unfair to the argument. You'll look at an argument that's perfectly good and act like it's not, like in the smoking case. Sometimes, as with a lot of people in COVID risks, I think you'll treat the argument as proving more than it does, right? Proving that it probably won't kill you is not proving that it definitely won't. We will focus on deductive arguments in this course. Deductive arguments, for reasons I'll get into in the next few lectures, are much easier to evaluate. There are some forms of deductive argument that are valid. We'll talk about what valid means in the next lecture, but, valid arguments are, in one sense at least, they check one box on the way to being a good argument, right? And you can recognize fairly easily whether deductive arguments have this form that makes them valid. Deductive arguments are also, at least as far as the form goes, all or nothing. We'll talk about this next lecture, but, a deductive argument is either valid or it's not. It does not come in degrees, at least on that part, right? Inductive arguments come in degrees. All the way from terrible to great. The better it is, the more likely it makes its conclusion true. But the very fact, that they kind of exist on a spectrum and are not just sort of cut and dried makes them harder to evaluate than deductive arguments. You also run into a lot more math with inductive arguments. You pretty quickly, not super complicated math, but you very quickly have to at least divide by and multiply by fractions. I don't know your level of math phobia. Whenever I say that, though, I can always guarantee somebody's face will just, go into pure panic, right? Don't worry, we're not really going to talk about inductive. Just be able to sort them out. But you should know inductive are important. Even though we're not going to talk about them in this class, they're important arguments, and people make just loads of mistakes with them. Just all kinds of dumb mistakes people make with inductive arguments. If you're interested in inductive arguments, there's a really good book on inductive logic, Odds and Ends by this guy Jonathan Weisberg. You can find it at, the address is here. I'm not going to read through an internet address, but you can copy that down, right? Weisberg's book is really, really good. If you're at all interested in inductive arguments, I would recommend you take a look at it. There's a bit of math to it. You have to, like I said, add, multiply, subtract, and divide fractions, but it's not that complicated. It's also free. So, take a look. There's no risk. You can find it here, both as a website and a PDF file. If you are interested in inductive arguments, and especially if, you kind of like mathy sort of things, I really, really recommend this book. We're not going to talk about it. I'm not going to quiz you on it in the class. Just be aware that it's out there. One final thing I will say is that Weisberg, who's now a professor at the University of Toronto, actually started his academic career at community college, which I also think is pretty cool. All right. Anyway. So that's the distinction between deductive and inductive arguments. We're going to leave inductive arguments behind for these lectures on argument and mostly in this class, but I do want you guys to be able to sort out the difference between them. We will very prominently later in the semester, there's one inductive argument. Nick Bostrom has this simulation argument. That's an inductive argument, so we're not going to leave them behind entirely. One really important one will come up, but for the most part, we're going to focus on deductive arguments.